Hello everyone. My name is Vishal. So I'm gonna talk about this week's lecture where we, dive into the foundation of propositional logic. We started with syntax, which is basically the grammar of logic. We also use that. We learned that we use a signature, so like a set of symbol like A, B, or C to represent variables. By combining these variable operators like, you know and or and not, we can build complex formulas. For example, instead of just saying it's raining, we can create formula rule. If it is raining, then the street is wet. Yeah. So and then moving on to semantics and truth tables. But logic isn't just about symbols, it's about semantics or meaning. We assign truth values, true, you know, false to our variable to see every possible outcome of a formula. We use truth tables. This is a powerful proof system. For instance, we explored how a disjunction is true if at least one part is true, whereas a conjunction requires both to be true. So, one of the trickiest part was implications. You know, remember, if A, then B, it's only false if A happens but B doesn't. You know what I mean? So, yeah. And then about the equivalence and logical law, we also learned that different looking formulas can actually mean the same thing, but this is called semantic equivalence. So, we studied laws like De Morgan's law, which helps us simplify negotiation of and or statements. So, and then there is a key takeaway was the difference between formulas. A tautology is a formula that is always true, like it's either raining or it's not. We also touched on entailment, which is when a conclusion must be true if our knowledge base is true. And then finally, we looked into CNF, which is a specific way of organizing formulas into groups or clause. And then what we found most interesting is how these abstract symbols apply to the real world, in mathematics and computer science. These concepts are bedrock of circuit design and software verifications. Yeah, with that, I would like to conclude today's thing. Thank you.